my cat is sitting on my paper. I had promised that I would send you some examples and show you a little shortcut trick when you're using the horizontal asymptote. So I want to just go through that with you. There are three types of rational functions that you can be asked about in terms of asymptotes, okay? So let's take a look at the three kinds and how they're different from each other. The first one I'm going to give you is if we had something like y equals 5x plus 1 over 2x. When we're asked to find a horizontal asymptote for a function like this one, then what you're doing for a horizontal asymptote is finding the limit as x approaches infinity. And so we talked about this a little bit with the money. We were talking about this when you had to leave the other night. That if you had infinity dollars and then I said, hey, happy birthday, here's another dollar, then that dollar you would be, yeah, you just keep that, I don't need it, I've got infinity dollars, right? It would be very insignificant compared to how much you already have. And so that's exactly what we're going to do here. We're going to just look at that as being insignificant, which means we can take it out of the equation. It's not going to make any difference. Like if you have infinity plus 1 over infinity, you know what I mean? Like it's still infinity over infinity, right? And so all we need to look at now is the equation that we have left. And you notice that it's just 5x over 2x. And if I was going to simplify that, I would go x divides into x. And so it doesn't matter what the value of x is, I'm always going to get 5 over 2 when I do that. Therefore, my HA is y equals 5 over 2. So this rule is the rule for when the exponent, when the highest exponent in the numerator and the denominator is the same. We have x to the 1 in the top and x to the 1 in the bottom and no other exponents of x. When that happens, it's the coefficients of those x terms, or x squared or x cubed or whatever they are, that tells you the equation of the HA. So that's really straightforward, and that's really easy to find the HA if you look at it that way, okay? So another example would be if I gave you something like 5x plus 1, and then it was divided by x squared instead of 2x. And so if that were the case, and I'm looking at the degree of the numerator compared to the degree of the denominator, I notice that the denominator is bigger, right? So again, when I do the lim as x approaches infinity, that 1 is insignificant. And so we're just going to have like 5x on the top and x squared on the bottom. But if we take that idea one step further, then we've got infinity over infinity squared. And infinity squared is much larger than infinity. And so what that does is it makes this whole term insignificant. It makes it just basically like 1 over x squared. So when I put in my infinity for x, it's going to give me 1 over infinity, or in this case 1 over infinity squared, and the limit of that value is 0. So anytime that the denominator has a higher degree or a higher exponent than the numerator, the HA is always y equals 0, always. Okay, now those are the two times that you're going to get an HA. The other type of rational function that you could get would be if we had something like this, where the numerator degree is higher than the denominator degree. When that happens, there is no HA. What happens there is you're going to get an OA, which is an oblique asymptote, and I don't think from talking to students in your class that you have actually done this yet. Sometimes profs will call it a slant asymptote. And what it is it's an asymptote just like the others, but it comes in the form of a diagonal line or a parabola, even a cubic. It can be all sorts of different shapes, but it's not going to be a horizontal or vertical line. So I'm not sure if you've got here yet, but if you have a look and you see a higher degree on the top than you do on the bottom, then that's a situation where you're not going to get an HA. All right. If you are talking about OAs and you think you need to do those for your upcoming test, then let me know by email, excuse me, and I will make you another video to explain that, okay?